In this video, we're going to be naming and writing formulas for compounds called ternary ionic compounds, which are basically ionic compounds that contain a polyatomic ion. So they contain a metal and a polyatomic ion. So really, if you notice that metal there, you're dealing with ionic. But if you have a metal and polyatomic ion, it's a ternary ionic, meaning it's not just binary anymore. There's more than two elements in there because polyatomic ions have, well, more than one atom within it. So a polyatomic ion is an ion that's made up of more than one atom and is charged. So for example, NO3 minus has four atoms, N and three O's covalently bonded to each other, but overall collectively they have a minus charge. This by itself, this NO3 minus, is not a compound because it has an overall charge of -1. Remember, a compound, if it's an ionic compound, overall has to have an overall charge of 0. So how do we get a charge of 0? Well, we have to combine it with something with a positive charge, like let's say sodium plus. So Na plus, NO3 minus, together would be an overall charge of 0. That would be an overall compound. So these that you see here, they're not compounds. They're polyatomic ions. They're groups of atoms covalently bonded together with an overall charge, and because they have an overall charge that's negative, they can bond to a positive charge somewhere. Most polyatomic ions will have a negative charge, but there are some exceptions like ammonium, which is NH4 plus, that has a positive charge overall, +1. So it will attach to an anion rather than a cation. So let's just go to our handout here for a second. So we're dealing with ternary ionic compounds as opposed to binary. So a binary example would be, let's say, NaCl, that'd be binary. There's only two different elements there. A ternary ionic compound would be NaNO3. There is a metal and a polyatomic ion. Or you might have NH4Cl, a polyatomic ion with a non-metal. This is kind of one of the exceptions because it's a positive polyatomic ion, but the point is you have more than two different elements. You have three or more different elements there. And that's why we call it ternary ionic. Usually that metal is what gives it away, or the positive cation like NH4 plus. So this would be just binary. So we're going to learn how to memorize the common polyatomic ions. There are some you need to know. For the most part, there are common ones that are pretty straightforward to know, but then there's others that you need to derive, to come up with on your own. So if we look in our table here, you do have most of the polyatomic ions given to you, most of the main ones, but then there are some that you have to come up with based on the main ones, and I'll teach you how to do that. So let's go back to our handout here. The main ones that you're responsible for knowing are cyanide, Cn minus, hydroxide, OH minus, ammonium, this is wrong here, this should be NH4 and the plus on top. So it's 4 hydrogens, 1 N, and then the plus on top. So ammonium and the 5/8, and we'll go over the 5/8 in a bit, but the 5/8 have what's called derivatives, meaning you can come up with other ones based on the 5/8. So let's go take a look at what the 5/8 are, and we'll go take a look at how we can come up with their derivatives. The derivatives are also called altered polyatomic ions. They're basically polyatomic ions based off of these 5/8 here. So, for example, carbonate, nitrate, chlorate, sulfate, phosphate. Those are your 5/8. So there's a few tricks that you can use to remember your 5/8, and then I'll show you some tricks to come up with the ones based off your 5/8. So let's go to our presentation here. So again, these are the common ones you need to know in your 5/8. And the trick that you can use to remember your 5/8 is Nick the camel ate clam for supper in Phoenix. So these will help you remember nitrate, carbonate, chlorate, sulfate, phosphate. It doesn't only help you remember the name, it helps you remember the charge and the number of atoms as well. Let's go through the table to show you that. So if we look here, Nick, the first letter N is what the polyatomic ion starts with. So N. The consonants, so N, C, and K, there's three of them. tells you the number of O's, so NO3. And the vowel tells you the charge, 1 minus. Camel, C starts with a C. Consonants, 1, 2, 3. There's CML, 3 O's. Charge, well, there's 2 vowels, A and E. So that's carbonate, CO3, 2 minus. Clam, so starts with a C, Cl. There's 3 constants, CLM, so O3. And there's 1 vowel, so minus 1. This works for all the other hydrogens as well. So there's chlorate. Fluorate is basically FO3 minus 1. Bromate is BrO3 minus 1. Iodate is IO3 minus 1. So that applies to all that for that trick. Supper, S is what it starts with. How many O's? Well, there's 1, 2, 3. So 1 S, 2 P's, 1 R. There's 4 O's. And then 2 vowels for the charge of negative 2. And phosphate, finally, P is what it starts with. How many O's? Well, there's PH, so that's 2 consonants, NX, N afterwards as well, so that there will be a charge of negative 3. And then we have, the consonants are the number of O's. I forgot that there was an X there. So PH, N, and X, those are 4 O's. And then we have 1, 2, O, E, I, 3 vowels, which is a charge of negative 3. So you can remember those formulas and the charges using the mnemonic, the memory aid, Nick the camel, 8 clam for supper in Phoenix, to help you remember the 5 eighths. I wouldn't waste your time just sitting there trying to memorize them. I would try to practice with them as much as possible, because that will help you to do that. That will help you to memorize just as you practice naming and writing formulas for them. So let's go take a look at how we can come up with derivatives, altered polyatomic ions, based off of your 5 eighths. So let's go back to our handout here. So just remember to go back to take a look at that trick for the 5 eighths. There's a video here that goes over that trick as well for the Nick the Camel trick. So if you want to figure out your polyatomic ions that are altered, what you do is you're going to start with the parent polyatomic ion, which is the 8 polyatomic ion. If you want to get the ite version of it, what you do is you remove 1 O from the 8. So for example, nitrate is NO3 minus. To get nitrite, you just remove an O and it's NO2 minus. The charge stays the same. If you want to get the hypo-ite version, you remove 2 O's from the 8s. So for example, I have nitrate as NO3 minus. If I want to get hyponitrite, what that means is I remove 2 O's from NO3, which is NO minus. You can also get what's called a per 8 version. The per 8, per means 1 more. So you add an O to the 8 version. So if I want pernitrate, I would simply do NO3 minus, put an extra O there, NO4 minus. Charge stays the same. So you can do that for all of the 5 eighths polyatomic ions. For example, I'm going to try to find the derivatives for the chlorate polyatomic ion. So I'm going to put chlorate over here, chlorate. And I know chlorate is ClO3 minus, with an overall charge of minus there. If I want to get the one that's above that, so let's say I want ClO4, I know that I added an O, so that's my perchlorate. Now let's say I want a chlorite. Not chloride, chlorite. Chloride would be just Cl minus. So remember that. When you're dealing with polyatomic ions, you're usually seeing endings of ate or ite, with some exceptions, like ammonium, hydroxide, and cyanide. So you need to remember those exceptions. All the other ides that you typically see are going to be just the regular element by itself. So chlorite, back to that, sorry, that was an aside here, is 1 less than the chlorate. So ClO2 minus 1. So it's still -1 here, -1 here, -1. Charge is not changing. You can also get hypochlorite, and so that would be ClO, 1O less than the chlorite, -1. And so these could exist in compounds. So for example, I could have sodium hypochlorite, which would be, or let's do calcium hypochlorite, which would be Ca brackets ClO brackets 2. It's what's in the brackets that counts here, right? This on the outside just means there's 2 hypochlorites. I could have calcium chlorite, CaClO2, 2. That's in a compound. I could have calcium chlorate, ClClO3, 2. And I could have calcium perchlorate, CaClO4, 2. Likewise, I could have sodium hypochlorite, NaClO. I could have sodium chlorite, NaClO2. I could have sodium chlorate, NaClO3. And I could have sodium perchlorate, NaClO4. We'll go over naming and formula writing after, but right now I want you to get that polyatomic ions are groups of atoms that are covalently bonded but have an overall charge. When you make ionic compounds with polyatomic ions, you have something called ternary ionic compounds. They're no longer binary because they have more than 2 elements in them, more than 2 different elements. So the ones you need to remember are cyanide, hydroxide, and ammonium, plus the 5/8 and their derivatives. And we saw a trick to remember the 5/8, Nick the Camel. And we saw how to come up with the derivatives or the altered polyatomic ions by adding or removing oxygens and changing the ending to "ite" and adding the prefix "per" or "hypo," depending on whether you added or removed. And we did an example with chlorate to find all of its families. I encourage you to practice this with all the other polyatomic ions. The 5/8 rather, and so you can see some more examples done with chlorate there. Just in case you didn't quite like the way I did it, you can see it organized in a different way here. But do practice it with things like bromate, fluorate, iodate as well, carbonate and sulfate, and see if you can derive them. Same thing with the phosphate. In the next video, we're going to learn how to name and write formulas for ternary compounds now that we know how to derive polyatomic ions.